XR devices are getting smarter, and AI, especially LLMs, are advancing rapidly. Their intersection marks an exciting frontier, where AI meets XR. We introduced AIvaluateXR, a framework for evaluating large language models running locally on XR devices. We also showcased key benchmarking results and compared on-device LLMs with client-server and cloud-based alternatives. ChatGPT has revolutionized science and technology, but it relies on internet connectivity. However, we need on-device AI that works without internet, due to government restrictions, firewalls, remote areas, or privacy needs. This is particularly important for extended reality, enabling real-time, private, cost-effective AI experiences with low latency, enhanced security, and offline capabilities. Running on-device LLMs requires identifying optimal combinations of models, devices, and parameters. AIvaluateXR helps automate and guide this decision-making process. Using AIvaluateXR, we evaluated 17 LLMs on 4 XR devices, spanning 68 model device combinations. In our pipeline, we first deployed LLMs on XR devices and identified key performance factors through an initial investigation. Based on these factors, we defined evaluation criteria and conducted experiments. Finally, we performed a 3D Pareto analysis to determine the Pareto front, highlighting the best-performing model-device pairs. We also compared on-device LLMs with cloud-based LLMs in terms of efficiency and accuracy, using a set of queries from an XR dataset used for interactive applications. We tested consistency over 20 runs and analyzed prompt processing, token generation, thread, and batch tests with varying parameters. These are the consistency results of 20 runs for each devices in tokens per second. Consistency varies by model, with only a few fluctuating in each device. However, MetaQuest 3 exhibited greater inconsistencies. Changing string length impacts performance, with shorter strings being more efficient and producing fewer errors. MetaQuest 3 and Apple Vision Pro are the most affected by this variation. Smaller batch sizes are more efficient, while larger ones reduce efficiency. Thread counts between 4 and 8 yield optimal performance. GPU results, however, did not degrade with varying batch sizes and thread counts. We also counted errors, tested memory, and battery consumptions. Finally, we performed a 3D Pareto analysis incorporating all results to identify the Pareto front, highlighting the best-performing model-device pairs. Additionally, we compared the efficiency of on-device LLM with cloud-based and client-server deployments. Furthermore, we evaluated our on-device LLMs on 57 queries from 2 existing LLM-based interactive systems to provide a more contextual analysis. In conclusion, we benchmarked 68 model device pairs for LLMs on XR platforms. Apple Vision Pro delivered the best performance, followed by Magic Leap and MetaQuest 3, while Vivo performed relatively lower. The 3D Pareto front analysis highlighted the top-performing model device pairs. We believe that model compression and application-specific fine-tuning will further enhance both efficiency and accuracy. With these advances, on-device LLMs are not only feasible, they are inevitable. AIvaluateXR stands ready to guide this transition, shaping the future where AI meets XR. For more details, please read our paper. Thank you.